Whoa.
Okay, I think maybe Brian or Peter, the first thing I kind of wanted to do was lay out a roadmap for Flux training in terms of what's already there and what we still need to do so that we can kind of start consolidating things and plan a little bit better.
Sounds great to me.
Yep, sounds great to me.
Okay,
So,
well, yeah, go ahead.
I would think that the next thing to do is to take one of the more popular FastAI examples and implement it with our FastAI, and say this is what this one would be like done with us.
So I think a lot of folks have seen this already, but in the Flux training repo, there's an example notebook, let me post it here, that uses ImageNet, which is the FastAI kind of like boilerplate vision data set. I think it's out of date because I tried running it for a PR I was making over the weekend, and there was a lot of stuff missing. So I think getting that cleaned up to date, working with all of the stuff that we've discussed would be a good start, because it trains and it demonstrates like the learning rate finder, like all the, so at least a good chunk of the kind of core functionality you see in the FastAI tutorial. It doesn't have any of the higher level abstractions, so this would probably be closer to the, if folks are familiar with it, the mid-level or advanced, sorry, intermediate or advanced tutorials on the FastAI site.
Do we have transfer learning functionality?
I don't know. I know Lorenzo's working on, what was it? One of the projects. The thing with trying to create like a high-level interface for different phases of training. Oh, deep learning tasks. Hold on. A lot of links, so bear with me here. So
sorry, I got a question. I'm new. I just saw this link. I'm sorry to. What the equivalent of pi? You see that? That was messed up.
The fly.
The fly.
The equivalent of PyTorch in Julia is what? Or is that Flux? Okay. All right, that's fine.
So it's a little complicated.
Except it's Flux and Julia, because PyTorch re-implements a lot of like basic, types and mathematical functions in its own like silo. But the point of Julia is that like you're just using Julia.
Right, but like conv learner and batch normalization and these sorts of like machine learning, the math stuff.
So like PyTorch has the layers and then the AD system, right? So the AD system in Julia, well, there's a lot of them, but the one that's like the de facto one is Zygote, and that's what Flux uses. And Flux implements the layers that you're talking about, batch normalization, conv.
Okay.
And then on top of that, like schedulers and data augmentation and things like that are also in PyTorch is what we're working on right now. So that would be Flux training or FastAI.jl.
We're trying to capture best practices for training deep learning models.
And then there's CUDA arrays for CUDA arrays.
Okay. Yeah, I didn't want to take over. I was just, as I look at this, that'll help me.
Yeah, no problem. Questions are welcome.
Now, have you seen the Flux website or like the main website?
I see. Yeah, I see the Git. I see Git. The GitHub FluxML, and it has links to all kinds of stuff, I guess.
Yeah. Here's a link to like I guess the home page. So there you can find links to some of the other stuff that we've been talking about, like how we can use the GPU, how we do differentiation, stuff like that. And then there's like docs and tutorials and stuff there too. So
So you
actually-
guys are Flux.
Not
we're
exactly.
Flux Community Edition. So
Yeah.
there's Flux ML, the organization, is like a small team of developers. And we contribute to Flux, but we're not part of the core development team.
Or Flux's friends.
Okay.
I guess that's the nature of open source.
It's kind of like how you have PyTorch, the core developers, mostly from like Facebook or Microsoft or whatever, working on the AD, the basic layers, and then you have all of these packages like FastAI that are building on that foundation. So we're not doing any of the core work, at least not yet, but we're trying to build all the convenience features that people have come to expect from a framework like, say, FastAI or Keras or PyTorch Lightning or Ignite or what have you, on top of the AD and layer primitives. And then if we find anything that doesn't work very well, we can always push that back upstream. But we're not planning on doing any active development, at least. We're not planning on focusing on that, is what I'm trying to say.
Okay. Cool.
But we do have a line into the Flux core developers. So if there's anything we need, they are open to listening to us, or they'd like our feedback.
Yeah, just for example, not to call them out, but Julian here, for example, works on the GPU stack in Julia, which Flux interoperates with. So like yes, we're a community effort, but there's a lot of connections and back and forth going on as well. Hopefully that clarifies things somewhat. We should probably have like an architecture diagram eventually, but we'll get there. Yeah.
Yeah, I mean, I have some. I'm interested in learning Julia, and I'm learning FastAI, and I have a background in machine learning. So I maybe is there someone that I could talk to so that I don't eat up the group time? I mean,
Do you know about
contributing, or I mean, maybe I'll just look at the repo and start chatting people.
Are you on the Slack channel or the Zulip
No.
channel?
No.
Oh, okay. That'd be good.
Okay.
Let me grab those links.
Join either Slack or Zulip, and anyone here be happy to answer your questions.
All
Plus
right.
more people.
Thanks.
Yeah, so the link that Brian just shared is on Zulip, where this group in particular kind of discusses things offline. But if you go to the link that I sent, the community link, that will have a section called chat right at the top, and there's a invite link for Slack and for Zulip there. And so I think to get started, there isn't necessarily one person to talk to about contributing, but if you join either of those two chat apps and then join the machine learning channel, there'll be people there who can then help further guide you to whatever package you need to go for what you want to contribute.
Okay, cool. Thanks.
And then I just posted a link to learning resources for Julia.
Oh, and I mean, of course, we're always looking for help. So, if you feel you're up to speed and want to help with any of the projects that this group in particular is working on, um, we're happy to have your help.
So are we basically not doing the abstract DAG thing? What do we settle on regarding that?
I mean, I don't think it's something that we're going to do as a first step necessarily. Well, maybe if someone's really invested in the DAG stuff, and I'm almost willing to bet it's going to be Lorenz. He or someone can replace what's already in Flux training with the abstract DAG. So Flux training is right now built on light graphs. For context for what we're talking about for everyone, Flux training is like FastAI, and it's basically a training loop. You have some model and a learner that fits that model to some data, and the way someone hooks into this training loop is through a series of callbacks. So when we're talking about the DAG, it's the compute graph of all the callbacks and all the stages in the training loop. And one of our goals is to be able to execute that DAG, in a multi-threaded fashion on various hardware platforms. So that if you have expensive callbacks, for example, recently on Zulip, we were talking about logging histograms of parameters and things like that. And if you want to do that, that can be a really expensive callback to run. And so you don't want to write that to, let's say, TensorBoard logger every single iteration. So being able to run the callback in parallel with the rest of the training loop is something that having a graph of the callbacks would let us do. And so that's what the abstract DAG work or package is about, is creating an interface for representing that DAG.
Just like FastAI, our version also has a learner and callbacks. It's the same basic design as the middle layers of FastAI, except it's done in a more idiomatic way, in an idiomatic for Julia way, and it supports things like the DAG and like multi-threading that you can't really do in Python. So hopefully it should be both familiar and superior for people that already know the Python version.
Okay, I think just to
Also-
close, go ahead.
Well, sorry, just Flux training is the training loop part of FastAI, and FastAI.jl is going to be an umbrella package that pulls in various components, that being one of them.
Yes.
So
So I think just to close out the roadmap discussion, I think what Flux training already has is, data loaders, soon to be not its own package, but part of ML data pattern. It has the training loops and the callbacks and everything in there. It has a learner. I think the things that are missing right now or that we haven't really discussed is data augmentation. And then, like Ari mentioned, eventually moving to the abstract DAG stuff. So maybe those two things should be our priorities for the foreseeable future on the roadmap. Does that make sense?
I think so, yes. I was going to also add that I'm just getting started on ONNX so that we can import models trained by other systems. So you can have your BERT or whatever, your VGG. And that, I think that should be part of this too, right? That you want to be able to do, as you were saying, transfer learning, right? That you need to be able to start with one of these models.
Yeah, and if we could interface that with whatever transfer learning stuff, like interface, like freezing and only training certain layers or training certain layers differently than other layers. I mean, FastAI has a high level interface to that. You could load the model and fine tune it and stuff. If we could get ONNX working with that,
Exactly.
so that should be on the
Fine, I'll
roadmap
add that.
somewhere.
Yeah, I'll add that. Julian, I saw you mentioned about Dagger. Has anyone mentioned anything about this abstract DAG stuff to you?
No, I haven't really been keeping track of any of the ML coordination stuff. So no. But if you want to point me to any links of what you're currently doing, please do. I can see if I can help out with that.
Yeah, I think Brian right above you posted a link to the Zulip stream discussing the DAG system. Basically, we had Shashi on the last call, and he walked us through Dagger and the interface in terms of having the delay function and the compute function and that kind of thing. And so the basic idea was to take stuff like delay and compute and put it in like a base package so that Dagger would implement that interface, and then some other scheduling package could also implement that interface, and then that basically would allow us to express a compute graph in flux training and then use different scheduling backends to actually execute the compute graph. Right now there's only really Dagger, but looking forward,
And okay, I'll read through the everything posted. But just for my understanding, what is the general purpose for abstracting out the DAG API? Like, why would you want to switch out Dagger for something else? Is it just like overhead or type stability or something else?
I mean, I think right now, the main thing that drove that was just that we didn't want to necessarily be locked in to a specific scheduler. I mean, I think there's another one, what is called Ray. That's another scheduler that we potentially wanted to use. And then the other thing that was brought up is sometimes the machine learning part is a small chunk of a larger scientific program. And that scientific program may use its own library to launch threads and different processes and things like that. And, it may not always be that Dagger will be compatible with whatever that library is in terms of running within a worker of another library. And so for that reason alone, maybe you want to like swap out the backend that Flux Training is using for scheduling the DAG.
If we, with the abstract DAG API, can we lower to just Julia's regular multi-thread scheduler, or does it need like a DAG representation?
I think on the last call, didn't Shashi say that that Dagger uses base tasks under the hood or something like that?
Right.
Yeah. It does
But-
currently.
but there is still an issue with compositionality, or no? I forgot.
I think
Like we want to be able to compose really well with normal multi-threaded code.
yeah, I think the point that was made at the last meeting was that Dagger, so you can compose something else inside Dagger as long as, so Dagger is running on multiple processes, and you can have something composed within that itself is multi-threaded, and so as long as it's using multiple threads within a single process, it's composable, but the other way around, it isn't. And that's just because the scheduler wouldn't be aware of the other library that's also launching processes on the cores.
I'll be there's a lot of development that's going to be, I mean, already, but will be going into Dagger because it's funded by, like, work is being done through Julia Lab to improve Dagger. I mean, that's pretty much my job. So I'm going to be adding support in the next few months for Dagger to be able to query the hardware and query the operating system and determine how much work is actually being done per CPU core, per GPU, pretty much all of that, and then dynamically adjust how much work is actually being scheduled to ensure that we don't oversubscribe. So Dagger will support that. And if Julia provides APIs for that too, then we'll certainly use them.
I think part of the reason we were not 100% on jumping on having a scheduler that would run stuff concurrently is that if you look at FastAI or any of these other libraries, their training loop is completely synchronous and it's single thread. Part of this is Python, of course, but I think part of it is also just the simplicity. What we're aiming with looking into stuff like Dagger is what if we could do something new and actually run some of this stuff in parallel, because it doesn't all need to run serially. But I think we weren't sure. I mean, we're still not sure if that's the correct API to do things, because this is a very, unlike, for example, like a parallel array map reduced type workflow, these are all very heterogeneous tasks. A lot of them, we won't know up front how IO bound or how compute bound they are, and they probably will be have very different overheads. So we weren't sure, and we're still not sure, if running them in parallel instead of just doing the plain thing and running everything serially makes sense. We would like to explore that, but we like to keep the option open to just have a very naive scheduler that basically runs a for loop and iterates over all the tasks in the main thread. So I think Dagger lets you do that, but just to contextualize why we're having the discussion about abstracting out the DAG part from the Dagger part.
Yeah, okay, that makes a ton of sense to me. So yeah, I'm on board with that. Let me know if I can help with anything related to Dagger, or the underlying API. I'd definitely be happy to help.
Awesome, thanks.
Should we move on to talking about augmentations? Because this is Lorenz's baby as well, but maybe we could get started at least talking about whether or not we want to continue with his idea, which was using like the Flex Training Universe augmentations library, or still trying to integrate with some of the Julia ML stuff. I think one problem we've had with that particular ecosystem is that it's kind of been, for lack of a better word, neglected for the past couple of years, modular whatever Julio has been doing. So I don't know. Thoughts? Concerns?
Wait, so what's the augmentation package from Julia ML? I thought the other package was called like augmenter.jl or something. Is that
Oh,
by Julia ML?
right. Sorry. So yeah, augmenter J.
That's for images specifically.
Right. I confused it with the Julia ML packages because the main author was contributing a lot to Julia ML, but then probably for whatever reason stopped contributing to a lot of the packages. He was a primary contributor to most of the Julia ML packages. Augmenter is maintained, so maybe that's a non-issue.
But I raised Augmenter with Lorenz, and he said something.
He said it wasn't good for non-image modalities, or at least anything which is not just an image. And I agree. Like personally, I had to rewrite a bunch of PyTorch augmentations recently because I'm not working with images.
Okay.
But I mean, would it be possible to add a more general interface for augmentation? Or is it just we go our own way and create another augmentation package totally separate from Augmenter?
Didn't he create augmentation? Didn't Lorenz have an augmentation package?
He does, but it's another package altogether.
Yeah, is it completely independent or is it built off of something?
I'm not sure. It has a bunch of. I don't think it relies on Augmenter, if that's what you mean, but it uses the. It's mostly image focused as well, because I think his work is also image focused, just not like image in, image out kind of thing.
So.
Yeah, because I mean, any of the data augmentation stuff, I mean, data augmentation is like a pipeline, or like the core design part is designing something that can express pipelines. So wouldn't it make sense to build off of, I guess, libraries that are good at expressing pipelines?
Like
I know there's what is it called? There's one that's under like an IBM heading. I think that might be ML focused.
Yeah.
Yeah, I think that's the one.
Yep.
Or MLJ. I mean, they have augmentation stuff, transforms, and pipeline.
Yeah, I don't. The MLJ is a heavy dependency though. Like, I also thought about that, but right now I think they have everything. Like they have MLJ base, but that only has a subset of the core functionality. And unless they define the augmentation interface in there, it might be a little tricky to work with that.
So whatever we do, whatever we decide on, can we have the data loading, the augmentation, the training, all right to the same DAG and just have everything run, have things run in parallel where it's safe, serial when it's not safe, and just coordinate the whole thing using all the cores and machines? Like,
so at least from my point of view, I think of the nodes and the DAG, like the coarseness of the granularity being coarser than what makes up the data pipeline. So there's a piece of data that eventually feeds into the model, and I think of that as the source, but that source actually being fed by the loading and augmentation pipeline. But in the at least as I'm visualizing it in the DAG, it's a source, not broken up into individual nodes. If that.
But does it matter if it's broken up into individual nodes? I mean, as long as those nodes know when to, as long as it's all scheduled properly, right?
Conceptually, it doesn't matter. I mean, perhaps it would be better to schedule that way, But from an implementation complexity perspective, if you just treat it as a opaque input, it's a lot easier to get started with that. You don't need to interop with your DAG or your DAG scheduler that way. And then you can just plug in any iterable and then just consume that as you would if you were doing so like on the main thread with a Flux training loop right now.
Yeah.
That
so
doesn't preclude doing the nested parallelism or putting them into the same DAG, but at least as a start, keeping it separate, I think makes more sense.
yeah, I think that was the main reason that I wanted to think of it that way, is because the augmentation and the data loading is something that could broadly benefit the Julia ecosystem. You know, it's not Flux training or FastAI focused. And so being as close to a generic iterable as possible, I think is something I would prefer, at least for that design, as opposed to being something that gets scheduled as part of the DAG.
My only concern is if it's, would it do its own parallelism? And if it's opaque, then will we step on that?
That's a good point. I mean, it does do its own parallelism. So, like in the agenda, for example, is which is like the first link I posted in the chat. There's a code example there of the data loaders, which I'll push sometime this week. I actually had a question for Lorenz, but he isn't here. But in there, there's a specific iterator called parallel obs for parallel observation, and that, I mean, that basically parallelizes or splits off everything that's feeding it into a separate thread from what's consuming it.
Right. So we just want to make sure that works with whatever solution we come up with for the training loop or whatever the FastAI specific portions are. Right. That's the only reason I'm talking about the granularity of the DAG.
Right. So I think the perfect is the enemy of the good here, in a sense. Yes, perhaps if they each have their own kind of parallel islands, then there will be some conflicts, maybe some contention, literal and metaphorical. But it'll be better than running everything on one thread, or rather, in this case, not having a data loading pipeline at all, because it'll take a while to bring one up to speed and turn into form that works with the DAG. So at least for getting started, I don't see any major concerns. We're not optimizing for performance yet anyways.
That's true, but if we use, so transducers has a Dagger execution backend. So if we just, instead of using the iterator interface, if we use the fold interface or whatever the equivalent is for transducers, I forgot. Maybe we could just get that all for free.
Yeah, I think that's, or at least when I was talking about the different pipeline packages, that's the one that has splittable space and stuff, right? So that's what I was thinking of.
Yeah. So we just say
for data augmentation.
We just say you just use Dagger. It'll write to the, I mean, theoretically it'll write to the DAG, then the training loop writes to the DAG, and it should just all work. I don't know. I mean, it sounds too good to be true, but.
Yeah, I mean, I think that's a good idea for data augmentation. For data loading, it's not, so the data loading pipeline, yes, is at the finest granularity, multiple nodes, but none of those nodes actually do any work. They're all just lazy wrappers, and then it's the final node itself that fetches the data. So it's really more of just running that entire pipeline in a separate thread from, you know, your main thread, than each thing in that pipeline consuming consuming execution time. So I think in the case of data loading, it's not really worth it to do anything more than an iterable. And just to clarify, the parallel observation iterable is like the last thing in the data loading pipeline. That'll actually force the pipeline to run in a separate thread. You can use that in like a for loop context with vanilla Flux. If you wanted to use Flux training instead, and Flux training is the one that's responsible for parallelizing stuff, then you could just drop that one iterable from the end of your pipeline, and let Flux training, worry about scheduling the data source node on like a separate worker or whatever.
Okay.
And that package that you mentioned, that was transducers, right?
Yeah, I mean, there's a whole folds ecosystem, and I don't know which parts are where right now, but it's in Julia folds.
Cool, just taking the notes.
So just to elaborate a bit for folks who haven't seen transducers, or seen it's pretty. If you've seen them in Clojure, it's pretty much what you can expect. Otherwise, it's best to think about the transducers package as a way to kind of reify like iterable operations at a higher level, so you can stage a bunch of them, fuse them together if need be, and then send them off to be scheduled so that they can be run in a more clever way than if you just did like operation 1, operation 2 in series in a big loop. What we're talking about now from the data loading perspective is that you have to feed an iterable into there somehow. So if you're working with PyTorch, and if you see the agenda document Kyle posted, you'll be familiar with creating like a data loader object that wraps a dataset object where you can poke at it almost like a normal list on our right. That's one way to do things. There's also in PyTorch and TensorFlow/Keras, you can wrap any generator iterable, which is example 2 in the agenda document, where you use a bunch of just combinators and they'll try their best to run everything in parallel and run stuff on multiple workers. So there are a few different design directions, not all of them mutually exclusive, and we're trying to prototype at least a couple so that we can figure out what works. Like I think all of these work right now to varying degrees, but some of them may be more ergonomic in the long run.
Thanks, Brian. Julian, do you have any? We've been talking about Dagger and composing stuff a lot. Do you have any? Are we on? Does this sound correct?
I'm not 100% sure. I'd probably need to see a code example. I haven't been heavily immersed in anything in the ML ecosystem for a while. I'm also kind of splitting my attention right now.
Okay, no problem. That's fine. It's cool.
Okay, well, I think we're almost near the top of the hour. And there's, I guess, just a couple other things that were on the agenda. One, I know you mentioned over the week, Ari, was datasets.jl. That's, for context for everyone, work that Chris Foster, I believe, and Shashi are doing. On having basically a way to represent data sets either on like a distributed file system or locally or online, and it's basically an extension to file trees with the addition of version control also for the data set. And I guess to comment on how we can support that, right now, the way the data loading pipeline, so we don't have any kind of data set API like FastAI or PyTorch does. We just have these functions in ML data sets that that are basically like a get index for loading the actual file from the disk. And the way the data set wrapper works, if you see it in the agenda, is there's a data set struct, and as one of its parameters, it takes the name of the data set, and basically using multiple dispatch, we just specialize on that parameter to route any calls to get index to the appropriate function that loads from disk. So whenever datasets.jl is ready and we start replacing everything in ML datasets with something that's built off of datasets.jl, I mean, we'd basically have to just change that routing logic that routes the call to get index to, whatever the corresponding function from the datasets.jl design would be. So I think on that front, at least, the design has been split up in a way that we could switch to whatever dataset management API we want later down the road as they become available.
Cool. And do we, yeah, that sounds exciting. Do we have any feedback for like the core team, AD, GPU, anything? Are we good on like batch size and memory usage and like basic stuff like that lately? Has anyone used like any of the new CUDA stuff?
I don't think Flux has been updated to support that yet, or at least there hasn't been a release of Flux that supports it. I don't know if it's on master. But yeah, I haven't done anything. I guess on that front, we were supposed to do the triage. We haven't done that. We should probably start doing that at some point.
Can we have like a basic like vision and like transform model and keep tabs on how they're doing?
Oh, yeah, so transform, like language models, is basically handled by transformers.jl. I don't think we want to invest any effort really in trying to do our own library or something like that.
No, I just mean like performance
yeah.
and memory usage. So we could use that library. We could, like run a CI on the library,
Yeah, no, I agree. And well, I guess the thing that's blocking that is that well, so for the vision models, before all the vision models, we had a student from MLH work on that over the summer, and I took her work and turned it into a PR to Metalhead. Now it's missing a couple models that were in Metalhead that are not in the work that she did. Like, I think it's called DenseNet. Yep. Thanks, Huda. Oh, I thought you were leaving. then
I am leaving, but yeah, I'm waiting for the link. I don't know if Ari is gonna post it here or on Slack. So I'm really like, I need to go in a minute still. Yeah, but
I just
oh,
posted
great.
the
Okay,
link to
perfect.
the meeting minutes,
Brian,
and
do it, thanks.
Zulip as well, I think, is above somewhere.
Got it. Yeah, I already saw the Zulip link. Okay, great. I have to go. Thanks for organizing the meeting, and hopefully
Thanks for
I'll
joining.
start to get more
Thank you.
involved. And all this stuff is very interesting to me. So yeah. See you later. Bye.
thanks for coming.
Yeah, bye.
No, so what I was going to say on that is just that someone, it's in terms of the order of things that are a priority, I guess that wasn't a priority for me. But if someone adds those models to that PR to Metalhead, then it can finally be merged, and then we'd actually have that benchmark to go off of. The other thing preventing that benchmark from being a reality is there's also a PR to a function called outdims. That's a PR for the main flux, and it's kind of just been sitting there. I don't know why it isn't getting merged, but every now and then I ping Daria about it. So because that function is something that the flux models rely on to build the model. So once that gets merged into the main flux and the additional models are added to the Metalhead PR, that would then get merged and people could build a benchmarking system on top of it.
Gotcha.
Okay, well, is there anything else that didn't get discussed that anyone wants to bring up?
In my my real job, I'm using LSTM with a conditional random field on top, and that doesn't work with Zygote. I 6 months ago I posted a bug. I'm wondering what the right way to get that fixed is.
I am wondering as well. So we should maybe connect with Azamat. I think that's how you pronounce his name, because he was doing a lot of RNN stuff, similar bugs. I don't think they kind of got patched, but I still don't think his models work. And this is one, like, that LSTM is probably one of the biggest regressions where like it just doesn't work right now, at least very well in Zygote. So we should definitely put that somewhere near we should consider that for the triage. I mean, I'd advocate it to be near the top, but depending on what other priorities we have, it should at least be on the list.
The best way to fix that might be to wait for the new AD, which is supposed to be out like an alpha-ish kind of thing in a couple weeks, I think.
Right. My understanding from Daria is that it does work, but there just hasn't been enough attention to it. And for whatever reason, perhaps a lot of folks who, like the SciML folks, don't use any of those code paths, for example, or the LSTMs at all. So just getting perhaps the right people together as part of the triage could get that going again, at least. Same for getting the model zoo up and running again. If you identify as a priority, maybe we'll finally get a CI for the model zoo, or get one of the 500 upgrade to Flex 0.11 and CUDA.jl PRs merged. So yeah, that I agree that triage is a priority.
Yeah, I mean, yeah, to be honest, I don't work with Flux in my day-to-day at this moment, just based on the projects I'm working on. And so I don't have a good sense of the issues. I know that the RNN stuff was like the inspiration for the triage, but maybe even if someone just started adding those issues to the ML tracker repo, once I have some issues there to work with, I can then start, putting whatever labels and stuff in to set up like a triage style system. And then maybe we can have some way where we like pick like the top 5 issues or top 3 issues and bring it up at every MLAD dev call, so that they get some attention.
Yeah, that would be great. I mean, I made kind of an omnibus issue for the Model Zoo stuff, but again, I don't even use the language in my day-to-day work, so I have even less of a kind of drive to get things in, or at least less context to work with. So if there are folks who do use it day-to-day and do have these pain points, maybe we can CC them on the issues or ask them to help us draft the issues, because again, our bandwidth is limited because we don't work with this day to day.
I actually perhaps unwisely am using it in my day-to-day work, and I do have it running in various large banks, but I'm stuck at 1.3. So because Zygote doesn't work for me.
Okay, I mean, I think that's definitely a good issue for triage. So if you have the issue already filed on Flux, like you mentioned, maybe if you just post it in the chat here or on Zulip, that can be like our first issue to put into the triage system.
I can find it. It's about 6 months old.
So should these be issues or like sub tasks, and then how does that go with the projects?
I mean,
there are a couple of ways to organize it.
Yeah, I don't know. It's almost kind of redundant because there is a triage project, or like the cards or project cards or whatever it's called. So it is kind of redundant to file an issue on the tracker that's just a forward pointer to an issue that's on Flux. I was thinking that the tracker issues could be more consolidated, so they could have multiple forward pointers to Flux issues, if things are related or there's repeated Flux issues. One of the things we can do with the tracker is when we start an issue on the tracker, as we find other issues in the Flux repo that are just the same thing over again, or will be fixed by the, fixing that bug, then we can just add those forward pointers to the single issue on the tracker. And, that's a way for us to realize that, okay, there's this one bug that's shown up in like tons of different Flux bugs. And so that's definitely a priority to fix. And then we can make that something that we alert. And then in terms of like the project panel, I think anytime an issue is filed on the tracker, if it's a triage issue, the idea is to label it as something that needs triage, and then it'll show up in that project panel under the like needs triage list. And someone will, by someone I mean one of us, will basically be responsible for going through that list and picking out the ones that they think are the most important to fix. And then those will basically be the ones that get brought up to the dev team. And when that bug fix comes in, we'll move those issues over to like the completed panel. And so that's kind of the pipeline I had envisioned for tracking this stuff.
That makes sense.
Okay, so or is there anything else, or should we end for today? Okay, I guess thanks everyone for coming, and you know, thanks Aaron and Julian for joining this time. Hopefully you guys can make it to the next one too. Yep. Yeah. See ya.
Thanks. Bye.
Thanks, everyone. Bye.
Uh,